Okay, and on to the last question for today, which is question 8, which is coincidentally also worth 8 marks, which might look scary, but it shouldn't be at all, because actually it only involves a few skills. We just have to keep applying them to sort of unpack the layers of the question. So it's about minimum points and maximum points, and finding those, and that's all cool, because we know that for minimums and maximums, I put a note on the side to remind myself, which is a good thing to do at the beginning of a question, is to, I guess, kind of like make notes. As we know that the derivative, the gradient function dy dx equals 0 at turning points or stationary points, or minimum maximum points. So I've put that on the side, and I'll use that a little bit later. Okay, so there's not too much I can do to begin with, because all I have is the second derivative. Yeah, I'm not going to make a third derivative, so I'm going to integrate that to find the gradient function, which is dy dx. So if I start off with that, so I want to get dy dx. I'm going to get that by integrating 2x minus 1. So that's going to give me x squared minus x plus c. And I have to have that plus c because I don't know what the constant value was, because when you derive it, it becomes 0. So I need to, I'm trying to find the coordinates of this other maximum point, which means I actually need the full equation of the gradient function. I don't want that plus c, I want to know what that number is. So I need to put in some information. So there's two things I know. I know that x squared minus x plus c, the gradient function, will equal 0 when I'm at a minimum point. And I know that the minimum point, at the minimum point, x is 3. So if I put in 3 for my x value, I know that that has to give me a value of 0, because the gradient is 0 at that point. And if I rearrange that, I'm going to get c is negative 6. Okay, so that's the first thing. So then I can sort of round that off by restating that whole equation now. So x squared minus x minus 6, that is the same as dy dx, the whole equation there. And this is why I've been telling you guys to get into the habit of actually not just finding the c value when you integrate, but also then rewriting it as the whole equation for yourself, just so that you can see it. And we're going to use this later. So that's the whole gradient function. So that's the first thing. So now we have to find this other turning point, the maximum point. So I'm going to pull this up here, and I'm going to again make that equal to 0, because we know that our turning points is when the derivative dy dx equals 0. When I factorise that, I see that my two solutions are 3 or negative 2. I already knew that 3 was a solution, because they've already told us that the turning point for the minimum is 3, negative 10. So I'm going to use the other point, which is x is negative 2. Now normally I would substitute that into the equation for y, and that would give me the y coordinate that goes with it, but I don't have the equation for y. So that means I'm going to have to do another integration. So y is going to be the same as integrating dy dx, which is x squared minus x minus 6. So that equals x cubed all over 3 minus x squared all over 2 minus 6x plus c. Again, I need to find out the c value, so I've got the whole equation, but I go back to this point I know, which is that the point 3, negative 10, is on the curve. So if I substitute in 3 for x, minus 6 times 3 plus c, that's all got to equal negative 10. And if I rearrange that and solve that, I get c is 3.5, or 7 over 2 if you're playing with fractions. So that means my whole equation for y is x cubed over 3 minus x squared over 2 minus 6x plus, I'm going to write it as a fraction, 7 over 2. Cool. And then all I need to do is find out what the y value is when x is -2. So if I substitute in, I'm going to move over here. If I substitute in -2 for x all the way along, being careful to use brackets because just to make sure our calculator works it out properly, all the way along there and work it out, I'm going to get 65 over 6. So what I've done actually on my calculator when I've worked it out is, and that should be a 3, sorry, there. What I've done is here, I've put in bracket -2, bracket to the power of 3, and then I've used the ABC button, so ABC3, so that I'm keeping it as a fraction, so when I'm finished my answer will be a fraction. So then, I'm running out of space, but if I go over here, the coordinate of my last turning point is -2, 65 over 6. Or of course that's 10 and 5/6 if you write it as an improper fraction.